This is the very simple problem only if you know the trigonometrical ratios. What I meant to say by trigonometrical ratios is that you need to know like on which of the quadrants the sine, cos, tan, cot, sec and cosec are positive or negative. So for this problem, you do not need to remember about the other like sine, tan, sec, cot, cosec. You just need to know that where, suppose this is 4 quadrant. In this quadrant, we draw 0 to 90 degree. In the second quadrant, we draw 90 degree to 180 degree. In the third quadrant, we draw 180 to 270 degree. And in the fourth quadrant, we draw 270 degree to 360 degree. So let me tell you, I think in one of my videos in differentiation, I have described that part. Although as the concept is required in this problem, I am explaining it again. Okay. So in the first quadrant, all the trigonometrical functions like sine, cos, tan, cot, sec and cosec all will be positive here in the first region, means within the 90 degree. If you check the values of sine, cos, tan, cot, sec and cosec from your class 9 or 10th book, I think, so you will get to see from 0 degree to 90 degree, neither of this trigonometrical function will give you the negative value. It can give you 0, but it will not give you any negative value. So in this quadrant, only sine and cosec will be positive. All the other trigonometrical functions will be negative. Okay. In this quadrant, only tan and cot will be positive. And in this quadrant, only cos and sec will be positive. So we have given that we need to find the value of f dash. Imagine f dash x. We need to find the value of f dash x where x equals to 3 pi by 4. That means x equals to 3 pi by 4. So let me tell you, 3 pi by 4 means 135 degree, because 3 pi by 4 actually equals to 3 into pi by 4 means 45 degree. So it will become 135 degree. So 135 degree lies in second quadrant, right? 135 degree will be lying in the second quadrant, and we know in the second quadrant cos will be negative. We know in the second quadrant only sine and cosec will be positive. So all the other trigonometrical functions will be negative. So cos will be negative in this quadrant. So from fx we can write fx will be minus of cos x. Why? As we need to find the value of f dash x when x equals to 3 pi by 4, that means 135 degree. Okay, so if fx is minus cos x, so can we write f dash x? That means we are differentiating both the sides with respect to x. So can I write f dash x as sin x? Because differentiation of cos x is minus sin x, and already there is a minus. So f dash x will become sin x. So what will be the value? Now in place of x, we will be replacing 3 pi by 4, that means 135 degree. So if we are replacing 3 pi by 4, it will become sine 90 degree into 1 plus pi by 4. It becomes 3 pi by 4. 90 degree can be represented as pi by 2, as you know. Okay. So 90 degree into 1 plus pi by 4. That means in the second quadrant 135 degree, and in the second quadrant sine is positive, right? Sine is positive, but as it is as 90 got multiplied by an odd number, so we have to write the complementary angles of sine. That means we need to write the cos. So we need to write cos of pi by 4. That means we need to write the value of cos of pi by 4, which is 1 by root 2. Just check the process, pause the video step by step and listen to me very carefully what I said and what I did in the problem. You will be understand. Okay. So we'll move on to the next problem now. Now we will be solving and wonderful, interesting problem. It will be solved within 3 to 4 lines, but it needs a serious conception and a bit of intelligence. Okay, I will help you to get that one. Okay. Okay, so what is given that if for all x, fx to the power n equals to f of nx, then we need to find the value of f dash x into f nx, right? So as we know that, we can only get the value of f dash x if we differentiate the fx term, right? So start from this given expression, okay? Differentiate this expression, differentiate both the sides of this expression with respect to x. So we will get n fx to the power n minus 1. I hope you can relate why I have written this one. And again the derivative of fx, which will be f dash x. In the right hand side, what we have, we have f of nx. So that means we can write f dash of nx, and we need to do the derivative of nx will be only n, right? So as you can see, in both the sides we have n in the multiplicative form. So we can cancel out n easily from both the sides, right? And we need to find f dash x into f nx. We need to find f dash x into f nx. So what can be written now? Just look very closely. Okay. So you need to find f dash x. So you have f dash x in this side. Okay. But you do not have f of nx in the left side. So how to get that? Just see this step. Okay. So from here, can we write it as fx to the power n into f inverse of x? Just check what I have written. From here, I have written fx to the power n into f inverse of x. Okay. And the normal f dash x we are writing, and in this part we have f dash of nx, right? So we have the definition of fx to the power n as f of n into x. So we have the definition of fx to the power n as f dash of nx, right? So we can put f of nx as it is given here into, we are taking this f inverse x into this part. So f inverse x will become fx if we take from left side to the right hand side, right? So we can write f dash x, and we are taking this to the right hand side. So it will become f dash nx into f of x. Just you need to check this line. This line is very important. Very important line. Very important line. You need to check it and try to understand what I did. I am mentioning it again. From fx to the power n minus 1, it can be represented as fx to the power n into f inverse of x. And in the next line, we are taking f inverse of x into the right side. So in the right side, we will get f dash nx, and f inverse x will become fx after it goes to the right side from the left side. And in the left side, we have fx to the power n and f dash x. So instead of fx to the power n, we can definitely write f of nx. So we have written f of nx and just put f dash x. So in the result, what we need to find? We need to find f of nx into f dash x. F of nx into f dash x. Okay. So what is the value? So this is the value of the given question. It is f dash of nx into fx, right? So we'll move on to the next problem now. So in this problem, we have if fx equals to sin x and gx equals to x square, and hx equals to log x. So we have three different functions as fx, gx and hx. Trigonometrical function, algebraic function as well as the logarithmic function. Okay. So we need to find the d2p dx square. Okay. Given that the px, the p function is equals to h of g of f function. So that means we need to first calculate the p function, then we can differentiate and further differentiate it to get the value of d2p by dx square, right? So px equals to h of g of fx. So fx is sin x, right? Fx is sin x, so I have put sin x in place of fx. Okay. Now as per the definition, g function's definition, g of x equals to x square. That means g of sin x will be equals to sin x square or sin square x, you can say. So it can be represented as h of sin square x. We can write it because as g of x equals to x square, so g of sin x will be sin square x, right? So now we need to also do the h of sin square x. We know the h of x equals to log x. So the h of sin square x will be log of sin square x. Can we write that? What I did, I have just replaced x by sin x. So if hx equals to log x, then h of sin square x equals to log of sin square x, right? Now we have got the p function. Px means the p. Let me tell you, p equals to p of x you need to consider. Okay. So p equals to log of sin square x. Just now we need to at first differentiate it once to get the dp dx. We are differentiating with respect to x. So differentiation of log sin square x would be 1 by sin square x. For sin square x, the differentiation, we need to again do the differentiation for the sin square x. So it would become 2 sin x, and for sin x again the differentiation would be cos x. Okay, right? So now if we cancel out one sign from the denominator with this sign, so we will get 2 into cos x by sin x. So that means 2 into cot x. So this is our dp dx. So we need to again differentiate it with respect to x to get d2p by dx square, right? So if we again differentiate it with respect to x, we will get d2p by dx square. So 2 will be constant and differentiation of cot x with respect to x will be minus cosec square x. So our answer is, as you can see, minus 2 cosec square x. So by looking at the problem, initially you might have thought that it may go long and long. So I think you didn't expect that it can be solved within just 3 to 4 lines. Okay, just you need to proceed step by step. So what I did, we need to find the value of d2p by dx square. That means a double order differentiation, second order differentiation actually. Okay. So in terms of p, so we need to get the value of p first. So here we need to consider p as px. So and the as per the definition of px, it is given px equals to h of g of fx, right? So we have first put the value of fx, which is sin x. Now we see gx equals to x square, so g of sin x will be sin square x. Now we have h of sin square x. So as per the definition of h function, h of x equals to log x. So h of sin square x would be log of sin square x. Now we have differentiated it once to get the first order differentiation as 2 cot x, and again we have differentiated it to get the second order differentiation and the resulting answer. d2p by dx square equals to minus 2 cos square x. I hope you have understood the problem, right? We'll move on to the next video now.